Hello again, guys. So now moving on to the second video in this supplementary video series that I'm putting onto YouTube. Now we're dealing with the dual plenum design. Before we talked about how the single plenum intake manifold is meant for more higher RPM ranges and how it's more efficient at higher RPM ranges. And now we're going to deal with the other side of the coin, which is the dual style plenum. Okay, so but one thing we want to remember first is keep in mind Bernoulli's principle, what we actually discussed early on in the previous unit, that a constriction, when air flows through a constriction, right, you'll have a significant increase in velocity and also a decrease in pressure. Okay, you got to keep that in mind. Okay, so first let's look at some of the notes related to the dual plenum type intake. A dual plenum intake manifold divides the plenum chamber into essentially two parts. Each plenum within the intake delivers air to cylinders which complement each other according to the firing order. This allows for more balanced intake pulses acting on each plenum. The overall volume and area in each plenum is reduced in a dual plenum intake, thus improving and increasing volumetric efficiency and air velocity at low RPM ranges. However, there is less supply of ready-to-use air, but the decrease in pressure within the intake plenum happens much faster and with less effort. So remember when we were dealing with the single plenum intake, the single plenum chamber, because it's so much larger that once the engine starts going and you have all these intake pulses happening, there's almost like a larger storage area of ready-to-use air to be taken by each of your runners, right? But in this design, let's look at this picture actually. Okay, so the same thing applies as the other diagram. We have the imaginary line here, which denotes ambient, so atmospheric pressure, which is 14.7 psi, and this area would include your air box, air filter, your air induction hoses, and etc., right? And the area below this dotted line will represent air that has already been drawn into your plenum area, which should be less than 14.7 psi. And due to the difference in pressure, only then will air that is under atmospheric pressure be pushing air into our plenum. And remember we mentioned earlier, because of the extremely large area of the single plane intake, it requires more effort, more intake strokes actually have to occur before a drop in pressure actually occurs in a single plane plenum. Now, this is not to scale, obviously, but this is just to illustrate the point that if you took that single chamber plenum and now let's say you split it into two halves, okay, you can appreciate that now the volume and overall area of each plenum is reduced, okay? So if you think about what was happening in the single plane, because the area is now much smaller, right, in effect it would basically require less work to drop or to decrease the pressure in these smaller plenums because there's just less volume, right? And also it will require less intake strokes, less number of intake strokes, so essentially less RPMs to also create the pressure drop. So I guess the point is, because it's easier to create the pressure drop and you can create the pressure drop in here sooner, that means air is going to actually start moving sooner, right? So if you're going to talk about this from a practical standpoint, the engine's going to be way more responsive. As soon as you hit that throttle, as soon as the throttle plate opens, you're going to start to have movement of air very, very soon, okay? And going back to also a byproduct of this type of situation, you remember Bernoulli's principle. So these are just numbers I'm throwing out there. So let's say you have a 70 millimeter throttle body, okay, paired to a single plenum intake, and the opening is also 70 millimeters, so you're going to have air flowing through. But now let's say you took that single plenum and you split it into, let's say, two halves, okay? Well, I'll just say that now each half is going to be less than 70 millimeters. So this would essentially create a constriction in a way, which will create a Venturi effect. So because of that, air that's flowing through now a divided chamber, automatically it will increase in velocity. And remember, if you remember Bernoulli's principle, if it increases in velocity, it'll decrease in pressure. So in addition, you have the accelerated airflow creating a lower pressure area, which will promote air to move into this plenum a lot sooner and a lot easier, okay? So basically, in summation, an intake like this would be advantageous for everyday city and lower RPM range driving, just because the difference in pressure happens a lot sooner.